Welcome to the third module of the POSIX scripting course. In this module, we're supposed to cover the most of a very basic topic of scripting, the shell variables. They are the simplest means of shortening names for files, messages, commands, and so on. In short, variables are simple storage locations that can use a name. They represent a meaningful way to operate your environment, both interactively and in batch processing. We could assume without much mistaking that there's no script which wouldn't use them. Upon completion of this module, you will be able to do the following. Create POSIX shell variables. Create and use variables in a script. Mark some of variables for export to child processes. Retrieve the contents of a variable and use concatenation and substrings. By the UNIX definition, a variable is a container for data to be used by the shell, utility programs, or other Unix-based application. You can think of variables as a name-value association. By contrast with some strong-typed programming languages, shell variables do not need to be declared. One can just create and use them as needed. The shell will allocate memory on demand for variables and store them as strings. There are some advantages in doing so and some disadvantages too. Now, the syntax for creating or modifying a variable is variable equals value, or variable equals quote value string end quote. According to this practice, when the designated value contains more than one word, or perhaps some special characters, the whole story must be enclosed within quotes. Special attention must be paid for assigning values to variables. Unlike some advanced programming languages, in Unix no white space is accepted on either side of the equals character. Additionally, their names are case sensitive and by convention they are supposed to be written in uppercase, although this is not mandatory. There are, however, constraints when it comes to using them. A variable name must start with a letter, be alphanumeric, not to use any non-alphanumeric character except underscore, and not to include any space symbols. For assigning a value to a variable using literal text strings, be aware with the fact that a variable will always be created as a string variable unless the shell is instructed to handle it differently. The type definitions of variable in POSIX shell are covered in a later module. Let us approach some simple variable assignment examples. Each and every one of the following syntaxes is correct. So we can assign numbers, numerals, a simple string of characters, or complex sentences which can include several words. Now that we've covered the assignment syntax, let us examine how to use the contents of a variable. In order to access that, simply precede its name with a symbol $. This is a Unix-based convention. When the variable name is preceded by a $. Character, the shell will perform what is called a variable substitution in the command line, replacing the text variable $variable name with the contents of that variable. You could also enclose the name within curly braces and precede the opening brace with that $. Symbol. This is optional unless you need to concatenate the contents with additional data. Keep in mind, since the POSIX environment is case sensitive, the variable name must be typed exactly as when it was declared. Here are some examples, all being encapsulated within a single script. We will start by assigning a numerical value, immediately followed by printing this value on the screen. Next, we'll add some additional information in a more complex message, which will be easier to read. Consider this example as a method to append the contents of a variable to a fixed string. We will then check the behavior of such a message when enclosed firstly in ticks and afterwards in standard double quotes. Both these commands will show the name of the variable instead of performing what we've earlier called a variable expansion. What is important to keep in mind is that standard quotes will not prevent your interpreter to expand variables, whilst the single quotes will. Then we have two complex string associations, one without embracing quotes. You should always use them quotes when you plan to assign a complex string to a POSIX variable. Eventually, you can see two examples of a variable assignment, a bad one and the correct one at the end. Remember not to leave any space around the equals symbol. When variables are initialized, they are created as local variables within the current shell. Variables that are needed by a child process must be declared using the export command. This is the method which is effectively marking a variable for export. The export of variables allows them to be copied to child processes. A common practice is to have their names in uppercase, but this is not mandatory. Such an exported variable is also referred to as an environment variable because it will always exist in the environment of a child processes of the current shell, if you recall the fork exec sequence, as in opposition to the others which we name local data. An exported variable will only exist temporarily in subprocesses, the child processes of the current process. It is not really global, but rather a temporary copy. Thus, the child process gets copies of the environment variables from the parent shell and then discards them when it finishes. So these are not an effective means of sending information back to the parent process. Environment variables are shell variables that have been prepared for copy to child shells using the export command. Conventionally, they use uppercase names. Variables with lowercase names are supposed to represent user-defined variables. In opposition to environment variables, local shell variables only exist in the shell instance in which they are created. As you can see in the image, by convention, the shell uses variable names that consist of 3 or more uppercase characters. To avoid possible conflict with future releases of the shell, you may want to avoid using the uppercase variable names from the picture. Create variables using names that start with a lowercase alphabetic character. Use underscore to create variable names that describe their contents. For instance, file underscore name. Last but not least, try to use meaningful name for variables. As you might recall, user-defined variable names cannot start with a numeric character due to the fact that the numerals are reserved for use as parameter variables, which we will see in a later lesson. Additionally, variable names should not contain meta characters, and of course, no spaces are allowed within variable names. If the name of a shell-maintained variable is used in other scripts, the initially defined value could be lost the very next time that particular variable is used in a subsequent assignment command. If this happens during the current working session, it will be overwritten with no possibility to retrieve the original content. Therefore, avoid employing already used variable names when it comes to value assignment commands. In order to see how a variable is affected by the nested shell script calls, we will use a pair of variables in two scripts, and we're planning to override them. The names of these scripts are first.sh and second.sh, respectively. What you see on the screen is the code for the parent shell. The second will be the child shell, as you can figure out from this code. In the first place, we will assign values to the variables season and number. Although the first one is supposed to contain exclusively letters and the second one digits, from the shell interpreter's point of view, there is no difference between one and the other. Their names or content type is not significant for the test we're about to launch. Their initial values, well established in the parent shell, will be overwritten in the child shell and locally used for printing on the screen. We have three sets of messages, two of them being issued by the second shell and the third, as you can see on the screen, at the end of the first script. Here is the child shellcode. Of the two messages generated within the second shell, one will show the original values and the second the newly assigned values. When the child will achieve its end, the parent shell is supposed to regain the control and make another print on the screen command using what's left over from the child's flow. What do you think the final message will display for these variables? We hereby will resume our list of common practices and restriction in the use of shell variables. Environment variables are shell variables that have been exported for copy to child shells using the export command. In order to qualify to a such setup, these variables will be initialized within one of the system files, usually the .profile. This kind of setup ensures that each shell instance for that particular user will benefit from start of the list of these variables. By contrast, the locally defined shell variables would only exist in the shell in which they are created. By convention, the shell uses variable names that consist of 3 or more uppercase characters. To avoid possible conflict with future releases of the shell, you may want to avoid uppercase variable names. On the other hand, variables with lowercase names are considered user-defined variables. Variable names should not contain meta characters. User-defined variable names cannot start with a numeric character. The numeric characters are reserved for use as parameter variables, which we will see in the module 4. No spaces are allowed within a variable name. And if a shell maintained variable is used, the user-defined value will be subsequently lost the very next time that particular variable is overwritten by a new assignment command issued in the current instance. We have seen in one of the previous slides a means to integrate the content of a variable within a string. That and the concatenation operation are pretty much the same. Let's assume we want to add the letters IER to the initial value that's stored in a given variable. In our example, the last name. In order to achieve these, we will use the dollar symbol, curly braces around the variable's name, and the string IER. If you do not encapsulate the variable name in curly braces, the shell will treat the additional text as part of another virtually variable name. Since a variable with that name has a great probability to not be defined, it is very likely that no text will be rendered when the shell interprets that command. Let us just study the mechanism of extracting a substring from the contents of a variable. The variable substitution used in POSIX shell allows for some trimming before the value is returned. The trimming can be done from either left or the right side of the variable content. Those of you who have already experienced regarding shell scripting might object that there are some methods of doing this in a more explicit manner, using the cut command. Even if the information presented appears complicated, don't discard it. What you need to learn is that this is the most effective manner to do that. Just remember that these processing templates, shell patterns, are a basic feature of the shell, and we'll study in detail later in this course. For the moment, keep in mind that in order to extract substring from the contents of the shell variables, the POSIX shell has some integrated features. In the next two examples, we will use these POSIX features. The first script will remove the .ksh string from the origname variable. While in this second script, the actual trimming mechanism is slightly different, even if we intend to get the same result. Instead of using a fixed string, we will extract the information to the left of the point using the template %. This means that any other strings follows the dot symbol, including the dot, will be removed from the origname variable. Thus, the two scripts process the same thing, only by different techniques. We'll see in this slide other sources of data for variable assignment. We have seen so far the simplest way to assign contents for a variable. However, many other sources of data can be used to create variables. For instance, the shell can assign a value to a variable using another variable substitution. The shell can assign values to a variable using file name substitution. As we have already seen in our first lesson, the shell will first substitute for the characters used as a file name generation patterns, then assign the substitution string to the targeted variable. Finally, the shell can assign values to variable using command substitution. We are about to treat the third method of supplying data to a variable, output of UNIX commands. You can now see how this is achieved. It is about having a command encapsulated within parentheses and fitted with a dollar symbol. As with the file name substitution, the data replacement takes place before the substituted text is actually stored in the variable. As you can see in the displayed pipelines, commands can be simple ones or compound commands. The POSIX and corn shells have special syntaxes for output substitution on command line. There is an alternative to what you saw in the previous slide using the so-called command codes, also known as grave accent. In fact, the Bourne shell syntax is still valid in the POSIX and corn shell scripts. However, it is not considered a good practice to use them due to the difficulty to make a difference from the standard ticks. Instead, the POSIX syntax is preferred, which uses the dollar symbol and the standard parenthesis.